Cool. Thanks for having me here today. I am going to talk to you about how I use machine learning at Mashable to understand the audience for the content that we create. So my title, Machine Learning in the Wild, Techniques for Understanding Your Audience. So first, who am I? I'm a senior data scientist at Mashable in New York City. So I've come a very long way to be here today. It's also my very first time in Berlin, very lovely city. Yeah, I am one of the co-organizers for the NYC Python meetup, which I believe is the largest Python meetup group in the world with over 10,000 members. I'm a conference speaker. I speak at a number of conferences. I'm an O'Reilly Media author. I co-authored a book on machine learning and Python. And you can find me on Twitter at Sarah_Guido. Yes, my last name is pronounced Guido. Yeah, so I do all of my work in Python. I used to do Spark and Scala. Listening to the previous talk was kind of interesting, and I'm just glad I can do Python now. So, this is what I'm going to talk to you about today. I'm going to give you an overview of Mashable, which is really important for understanding all of the different use cases for machine learning that I'm going to talk about. So I'm going to just set up like what Mashable is, like what sort of audience we have and all of that. And then I'm going to talk about sort of 3 higher level categories: content engagement, audience segmentation, and social media strategy, and how I've applied machine learning to each of those segments, and then some wrap up with some takeaways. So this is more of an advanced level talk. I'm going to assume you know what machine learning is already. The difference between like unsupervised and supervised methods. I'm going to assume you understand basic algorithms like k-means clustering and linear regression. I'll explain a little bit about some of the more complex algorithms that I use. The goal for me is to show you how I use these methods in the wild, so to speak, so in my everyday work. So beyond just learning the theory in the classroom, like how are these methods actually applied? So, and how I apply these methods to my work at Mashable. So how many people have heard of Mashable? Okay, decent amount of you. So, for those of you that don't know, Mashable is a digital media site. We publish articles related to internet culture, related to like tech news, science, entertainment. We don't really do hard-hitting journalism. We do things like talk about what's happening on Twitter. Twitter is rethinking the blue check mark. We have a lot of I guess more lighthearted content, although I will say our science coverage of climate change and whatnot is pretty good if you're interested in that stuff. So this is sort of our brand statement, and this is directly tied into who our audience is. So Mashable is a media and entertainment company for super fans. We're not for the casually curious. We devour culture and tech. Our ideas shape the future, and we speak to new influencers and the early adopters who obsess with us around the globe. So we've been around for about 10 years, and so today we're finding ourselves at this juncture where we don't want to write about everything that's out there. There's a lot of stuff out there, and that's not the best use of our resources. There's a very specific subset of content that we're really good at writing about. So what we want to do is basically articulate who we want our readers to be in order to help shape our editorial coverage. So before we get into that, as far as the publishing landscape goes, publishing, 10, 15 years ago used to be you would read the newspaper or you would watch the evening news or something, and maybe you still do that. But now people rely really heavily on social media networks for their news distribution, and we're constantly receiving the news in a very asynchronous fashion. We're getting push notifications on our phones all the time for a variety of different content. There's not just one centralized place anymore. There's a variety of distribution networks. So in order to understand who our audience is and where they are and what they're doing, we have to understand the distribution networks first. So the business problem that we're trying to solve here is how can we understand our audience in order to know what content to write, optimize this content in real time, and deliver the right content to the right people at the right time, which is the ultimate goal and very difficult. So because of the way the publishing landscape has changed, we want to be able to understand the social diffusion of our content, so how our content spreads through social media networks, as well as the social diffusion of other publishers' content, thoroughly enough to gain a competitive advantage. So this brings us to our core problem here. So the first question we want to ask ourselves is, how do people interact with our content? And not just our content either. The first step that we took towards this is crafting this very particular brand statement in order to draw in a very specific audience that's really interested in the stuff that we're really good at writing about. So, you know, the internet culture stuff, the tech stuff, the entertainment stuff. You know, we're not trying to go out and get every facet of every audience ever, just this particular subset of it. So in light of the decentralized distribution networks that we have, sourcing content is the very first step in actually sort of crafting this audience. So we created something called the Velocity Suite to help with this sourcing problem. So the Velocity Suite is our main tool for helping the editorial team source content and figure out what to write about. And this sort of predates my tenure at Mashable a little bit, but it's really important for all of the audience work that we do because it really helps us understand the virality of content and how content goes viral. So the platform helps the editorial team source this content by crawling the web for content that is going viral. And we determine virality based on the velocity, if you will, of shares, so how quickly shares are accumulating. So the origin was to make content sourcing much easier for our editorial team. The product team at Mashable looked at the process that every writer was using to source their content and decided to try and automate this. So they took a survey of the landscape, and what this product does is rank what's on display by virality and use that to predict virality based on share counts. So it does this in an iterative fashion. So we crawl something multiple times, we update share counts, we predict virality. So what does this actually look like? So I don't know if you can see this. This is basically a time series of shares. Along the x-axis you have times, and then you have accumulated share counts on the y-axis. So Velocity crawls content across the web, tracks shares on social media, and uses that to predict future performance in an adaptive, iterative way. So what I mean by this, again, we don't just crawl something once. We crawl to get a share count, we make a prediction based on that share count, and then we also make a determination about when to crawl again for an updated share count. So when that time span is passed, we crawl again, getting an updated number for accumulated shares, and use that to make an updated prediction. So this prediction, the lighter blue, the not filled in blue there, is basically the prediction of the accumulated shares trajectory. So this will adapt as we crawl again and again, which is kind of nice. So to generate these predicted share counts, we build a model on the network of shares that occurs on a particular article. So we do this for each article. The network of shares is called a cascade. So the velocity algorithm is based on diffusion on a random graph, and it models what the probabilistic spread will look like and how the shares for the article are spreading through the graph. So it's basically like, how are these shares going to spread? What's the end count going to look like? The algorithm is time dependent, and it parameter fits probabilistically against the data that we've already seen in the cascade. So it makes determinations about the final prediction based on what we've already seen as well as what we're seeing now. It uses acceleration and the depth and curve of the accumulated share counts as well, and we end up with a prediction for the time scale. So at what point in time we're going to reach approximately 95% of the total shares that this article could possibly achieve. And it uses an evolutionary adaptive solver to do the parameter fitting. So this allows us to build out the social cascades for each article. So what does that look like? Here you have 6 different social diffusion graphs. If you look at the little small rectangles under the tree structures, you can kind of see that the patterns are similar. You know, we have an initial quick lift and then sort of a plateau growth there. However, if you look at the actual tree structures, they're vastly different. So figuring out what the actual graph looks like can be a little tricky. So let's look at how this works in practice. So this is a graph of, so this is like best case scenario. The blue line there is the accumulated shares over time. This was an example of very smooth growth. And then the yellow is the projected shares over time. So remember that the predictive aspect is adaptive and adjusts in real time to share counts that we're seeing basically on the move. So you can see like right at the beginning, the predictions are a little bit more unstable, but over time, you can see that the pattern of predictions sort of levels off a little bit. So like this is a best case scenario, like okay, final predictions sort of end kind of close to where the final share counts actually are. So this is also kind of interesting. For this particular article, it sort of was shared a little frequently at first and then accumulated a lot of share growth later on, and that's that blue line there is the actual shares over time. So this could be like an article was published on a lesser known site and then it was picked up somewhere else in like a much larger media outlet and shared. And you can see that the yellow, which is the projected shares over time, was actually able to adjust to what was happening in the blue, in the real segment, which is pretty cool. So sometimes the update algorithm can be a little finicky, and we end up with something like this. This is thankfully very rare, but it's very, very terrible. You can see like right at the beginning it's kind of okay, and then things just go like off the wall. And we're constantly working on the algorithm for our velocity suite, because obviously we don't want to like deliver this sort of information to our editorial team because that's really not helpful at all. So this is actually what the editorial team will see in our in-house product. So here's an example of an article: Husky showers baby with kisses during adorable play session. So like I said, we don't really do hard-hitting journalism. So this was like a really good proof of concept for the velocity suite. We discovered this article right as it was published. We collected a bunch of data points around it. There were several points where the share trajectory changed over time and the prediction was able to adapt to it. And then early projections very accurately modeled what was going to happen. So a good starting place for us in terms of understanding our audience is taking a look at the publishing landscape at large and identifying content that's going viral that we've determined would be very relevant to our audience. And this is how we start crafting an audience, by tailoring our content to a specific brand image. So that might sound like very like marketing speak, but again, consider that we don't want to necessarily draw in that's like extremely focused on only hard-hitting news. We want the audience interested in like cute husky videos. And so we kind of get this interesting feedback loop where we set out with the intention to craft an audience, and then that audience in return kind of comes back and crafts us and what we cover a little bit. So now that we have an audience, great, we have the audience, but what can we actually say about our audience? How do we describe what's going on, any sort of characteristics about our audience? And the way that we do that is with audience segmentation. So audience segmentation at a very high level is just a way of breaking down your audience into meaningful groups of people. So like Joe is 56 and drives a Mercedes and really likes reading about huskies. That would be like a very specific segmentation. But basically thinking about it in terms of like user profiles, like who are the real people behind just the numbers we're seeing when we look at our audience. So you can do audience segmentation in a variety of ways. You could go the third-party route. You could actually pay third-party software to do it for you. There are pros and cons to that. Pros, you can just use it out of the box. It's really easy for non-technical stakeholders to interpret, and they're the end user, so that was something that we considered. You can also automatically import data from a variety of sources, which means you don't have to worry about the ETL pipelines or anything like that. The cons is that they're not necessarily customized to your own particular audience or what they're interested in. So again, our audience is this very specific subset of like a much larger, all-encompassing audience. So when we think about audience segmentation, we wanted to think about it in a way that's really, really specific to the kind of content that we were producing. And then also, it can be sometimes unclear how third-party software generates their audience segments. So because, that's their secret sauce. So we decided that we wanted to go the in-house route because that would be a little bit more flexible. So the data that I used for this was from Google Analytics. So Google Analytics will give you back, if you send it a list of URLs to the API, you can get back information like the gender breakdown, the age bracket, and then the interest group of people browsing specific URLs. So when I say interest group, I mean things like movie lover or news junkie. So kind of, well, they may or may not be actually useful to the work that we're doing, but they're interesting nonetheless. Although it's kind of like, who isn't a movie lover? It's like some of their categories are so like all-encompassing that they may not be actually that useful. So anyway, the goals with audience segmentation were to give the editorial team profiles of users, identify groups of similar users within our audience, to analyze different sections of the site. So we have the Mashable main page, we have the Mashable culture page, the Mashable tech page. We wanted to see, are these audiences different on different sections of our site, and then use this to drive content creation. So this is a snapshot of the data that I used. So in the URL column, the demographics get returned on a URL by URL basis, and then in our features there are basically like the combinations of all gender, age, and interest groups in the set. So we have art and theater aficionados, which is our interest group. Age bracket is 18 to 24. Gender is female. And then, for all of the different interest groups and whatnot. So as you might imagine, this ends up being a very, very sparse matrix. And then the actual values are the percentage of that particular demographic set that is present on that URL. So in order to actually build the segmentation, we had to transform the data in this way. There ends up being something like 383 features in this set after we split out the feature set, which I know they tell you not to, create high dimensionality, but I assure you the curse of dimensionality has been broken. Or has it? We'll find out. So how should we model audience segmentation? Tried a few different methods that largely fell into two categories, clustering and also decomposing the audience. So you could go about this in a couple of ways. You could use k-means clustering, for example, to identify like groups of similar URLs in their demographic sets. But when we thought about that, there's more of a hard separation between the features. So you would have like all of the art aficionados in one group and then like all of the movie lovers in another group. And we kind of didn't want to do that. We kind of wanted to think about our audience a little bit more holistically. So we decided to go the decomposition route, which would create segments for us that are combinations of features rather than just hard separations of features. So I tried out a couple of methods for this, non-negative matrix factorization as well as archetypal analysis. So what are these methods? So archetypal analysis is really interesting. It finds, rather than finding cluster centers, it finds extremal points in the data to designate as archetypes. So archetypes, therefore, are a convex combination of identified features, and archetypal analysis favors features that represent corners, if you will, in the data. So not necessarily just like single feature points, but rather like corners and intersections of these features that are extremely distant from each other. And then non-negative matrix factorization, which I will henceforth refer to as NMF because that's a lot shorter to say, factors matrices in a way that allow for easier inspection. So NMF does a factorization that usually leads to two different matrices with a property that all of the matrices will then no longer have negative elements. So this non-negativity makes the resulting matrices a lot easier to inspect. It has some inherent clustering and decomposition properties in there through minimization of an error function. So the representation of the vectors that we end up with are obtained in an additive fashion by superimposing the components without subtracting. So then we end up with these clusters, segments, if you will, that are once again combinations of features. So both of these methods give us a way to think about our audience in a very holistic way. But which should we actually use? Or even before that, are the segments they create useful, and then which should we use? So here we have an example of a particular segment. So as it turns out, both of these methods sort of highlight some similar groups of people. So here is the most prominently identified segmentation result from each method. We will call this the millennial segment. There are a few differences. So if you can see, NMF weights male more heavily than female, while archetypal analysis primarily focuses on the 25 to 34 age bracket, but they're very similar. Similar age ranges. So like this probably isn't that interesting. Like we know that our audience is going to be millennials. So let's look at something that may be a little bit more interesting. So this is a more interesting segment. This is our fourth segment for NMF and archetypal analysis. And you can see both segments are weighted much more heavily female and also are primarily in the 55 to 64 age bracket. So it's especially interesting that both NMF and archetypal analysis agreed that this is a segment worth surfacing. So the other segments kind of varied. So it's kind of hard to say like which method we should particularly go with. Likely we would want to look at both and sort of figure out which tells sort of the best story. So a lot of it has to do with the story that we can tell the editorial team about their audience, because the editorial team is our end user for all of this work. So the question that we want to optimize for is what's the most accurate segmentation we can model that also is the most interpretable in a meaningful way to non-technical stakeholders. And that can be the hardest part sometimes is, you know, we have this data, we run some very complex transformations on it, and then we have to deliver it in a meaningful way to people without the same training or background in these methods. So one of the most important things I've learned so far at Mashable is that you might have a really excellent, sophisticated, state-of-the-art model, but first of all, if it's hard to interpret, and if it's hard to present in an actionable way to those stakeholders, is not necessarily useful. So the goal for us is to describe our audience as an answer to a business problem. So we have to be mindful of that in the work that we do so that we solve the problem for everyone and not just the data science team. But this was a particularly nice solution that we were able to actually talk to the editorial team about and say, hey, we found a couple really interesting segments, you know, is this useful to you? And then the next part of this project will be to actually sort of sit down and take a deeper look at the actual content that ends up in these different segments. And then we can try and piece together like, okay, this demographic is really interested in this very specific subset of content like Husky videos or something. So there were some caveats with the Google Analytics data. We were using the free version because the next level up I think was a little bit too expensive for us. So the data that I was working with was not super ideal. If we had paid for it, we probably would have gotten around some of these issues, but alas. So when I would hit the API, I would only really ever get back a third of data for a third of the URLs that I sent. The API would just sometimes not work. And then there's this like semi-useless interest data like movie lovers, which, okay, whatever. So like going forward, we want to find a much better source of demographic data, or maybe just actually give in and pay for Google Analytics. Okay, so now we thought about a way to describe our audience. Now we want to go out and find them. So again, we're thinking about a very decentralized distribution across social media channels. So we want to make sure that we're giving the right content to the right people at the right time. So the next logical question we can ask is, where is our audience and how do we reach them? So, okay. So first, a little bit of background about the state of Facebook. So pretty much most of our traffic comes from Facebook. If you're a publisher of any kind, most of your traffic is going to come from Facebook. That's just kind of how it is, and it's the game we have to play. So Mashable on Facebook, we have quite a number of different pages. We sort of have this like Mashable main page, and you can see it, the very top one up there, where traditionally we have put most of our content. And then we have a number of secondary pages. We have like the Mashable Tech page, we have you know, the news page, the France page, and so on. I just want to highlight on our main page, as of a couple days ago, we have 6.4 million followers. So this is like gigantic compared to the smaller pages that we have. So we have like, for Mashable Tech, we have 798,000. For Click, 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 we have 626,000. So when we think about how to distribute content, we have to do it in a way that is sustainable. So we can't just put all the content all the time onto our main page, because if you post too frequently to Facebook, the Facebook algorithm will actually punish you a little bit. So we have to be very strategic about where and when we place content. So in light of not only having a multitude of content, but also having a multitude of pages, you know, how do we think about developing an optimal Facebook strategy? So somewhere we can start when we think about this is there a relationship between views and shares on Facebook? And if there is a relationship, is it predictive, and what can we learn about it? So it is predictive. Spoiler alert. So for this project, which was actually like fairly simple but kind of interesting, the goal is to predict views from shares. So when we see shares on Facebook on a weekly basis, can we predict what the view counts are going to be? So this is a snapshot of the data that I used. I went back all the way to 2016. I grouped views by week. I was also using average engagements, so average number of shares. Oh, and when I say engagements, I mean like shares, likes, comments, and reactions on Facebook. So all the different things you can do on Facebook to engage with a particular piece of content. So total views, average engagements, the number of URLs we produced, and average engagements. So this is a very simple linear regression proposition. We also decided that we wanted to optimize for making the error rate as low as possible. So rather than try and optimize for a low R-squared, we decided to optimize for root mean squared error as well as mean absolute error. So R-squared will tell me how well the model fits the data, but doesn't necessarily tell me anything about errors or the magnitude of the errors. So root mean squared error is a standard deviation of residuals in a linear regression model. Measures the spread in the regression fit. It's basically a measure of the noise in the system. And also, mean absolute error is the average magnitude of errors, which is a little bit less sensitive to larger errors. So here we want to be very thoughtful about errors, because we want to use this data to have an idea of this. So if we publish n number of articles in a week and we publish them to these particular Facebook pages, it's likely that we're going to get like n number of views, which can then help the social teams meet their goals. So we want to really optimize for views here, and we want to make sure that the information we're delivering is as accurate as possible in terms of error rate. So again, very simple. So here are the predicted versus actual views over time. We got a pretty good model fit, and we were able to achieve decently low error rates. The blue is the week to predict, and then the green is the blue is the actual number, and then the green is the predicted number. So again, this is like a very, very simple application, but it's something that we hadn't discovered before, and that was actually like sort of hugely revolutionary to the editorial team. It was like, oh, okay, so now that we have an understanding that views and shares are have this relationship, we can be a lot more thoughtful about where and when we publish data, or where and when we publish articles. So another very important facet of this, when we think about developing an optimal Facebook strategy, is are we making any decisions that are actually harming us? So the thing about posting to Facebook is that a lot of people have a lot of preconceived notions of like what happens when you post on Facebook, or the mysterious Facebook algorithm. Like it's a common thought that when the Facebook algorithm changes, everyone's content suffers. We're actually working on a way to prove that that's not actually the case. But another, so we do some myth busting, if you will. And if the goal is to achieve as many views as possible on Facebook, we want to know if we're properly set up to achieve that goal. So the editorial team had a theory. They had a theory that once an article reaches 1,000 clicks on Twitter, it should be posted to our main Facebook page. And our main Facebook page is the one with like 6.4 million people. So what we want to know is this a good heuristic? So we produce a lot of content. We have limited resources for posting. We obviously can't put everything on Facebook, on our Facebook main page all the time, because if you publish, again, too many times in an hour or something, the algorithm will punish you. So one of the heuristics the social team was using was if something had around 1,000 clicks on Twitter, we would then publish it to the Facebook main page. So, you know, is this a good heuristic? Just intuitively, it's probably not, because the audiences on Facebook and Twitter are very different. But, you know, we want to go beyond intuition, so we wanted to prove it out scientifically. So the data that we have the number of clicks we get on Twitter, we have the Facebook page a particular article is posted to, we have the views performance. And using this, we can actually sort of dig in and figure out what's going on. So what does it mean to ask, is this a good heuristic? Good is a relative term, so let's define that a little bit more thoroughly. So we want to compare populations. So breaking down the problem, we want to compare populations. We want to compare articles that achieved at least 1,000 clicks on Twitter and were posted to main, and those that were not posted to main. We want to know if these populations are different. We want to know what the performances of articles on our Facebook main page in each of these populations, and then does using this heuristic perform better overall in terms of views than using absolutely no heuristic? So remember, the overall goal is to get as many views as possible when posting to Facebook. So what we're trying to figure out is, does this heuristic help us achieve this goal? So the first thing we want to figure out before we even do anything else that's a little bit more complicated is, are these populations statistically different? So we have population 1, which is articles that have achieved 1,000 clicks on Twitter and then were posted to our main page. Then we have population 2, articles that were not posted to main. So we have a main population and a not main population. So we can test the differences in these populations with a 2-sample Kolmogorov-Smirnov test. So KS test returns a p-value, and if it's lower than some threshold, like say 0.05, we can then say that the populations are statistically different. It's a non-parametric test of the equality of distributions. So ran this test, and we determined that these two distributions are statistically different, or these two populations are statistically different from each other and do not come from the same distribution. So that's good. We didn't think that they would. So the next thing we want to figure out, knowing that these populations are different, is we want to know the probability that an article with 1,000 clicks on Twitter and is posted to main outperforms an article that is not posted to main. You know, if you think about it, since our main audience is so large, if you post an article to main, it's probably going to get a lot more views than if you don't post it to main. But we want to understand what's going on here in the context of this 1,000 clicks on Twitter heuristic. So if, in fact, a 1,000-click Twitter article is, you know, maybe not likely to beat an article with less than 1,000 clicks or something, then the heuristic is kind of rendered useless. So to model this out, I use a technique called Gaussian process regression, which is a very, very elegant and awesome technique. So Gaussian process regression characterizes nonlinear relationships between variables. So it's a non-parametric approach which doesn't mean it has no parameters, but there is an infinitely large possibility of parameters. So you can use Gaussian process regression to find the distribution over functions that best fit the data that we're modeling. So why use this method? So because we get a full conditional distribution, we can calculate the probability that an article will achieve a certain number of page views, both using the heuristic and not. So the way that I did this was I built out 2 Gaussian process regression models, one on the main set and then one on the not main set, and then I built a simulation in order to see what would happen. So first, this is the regression, so this is log scaled. The dots are views data in the main and not main populations. If you can see the blue, that's the blue dots that are kind of higher up are the main population. The green are the not main population. And then the red line is the regression for the main population. So you can sort of see that posting to main does give a lift to views, but it's not like super clear cut. It's not like every time you're posting to main, you're beating out non-main pages every time. So how do we actually figure out what's going on here? So the method I used was to first build the models for each population. So you just saw that in the previous slide. So the next thing we want to do, something that Gaussian process regression was really great at, is sample a large number of times at Twitter clicks equals 1,000 for each of these regressions and make a prediction for views based on that sampling. So then we want to determine 2 things. We want to determine how frequently a main sample has higher page views than a not main sample by drawing from each sample a large number of times. This is using the Twitter heuristic. Then we also want to determine how frequently a randomly chosen main sample beats a not main sample, no heuristic. So all this to say, when we use the 1,000 click heuristic on Twitter, the 1,000 clicks on Twitter to post to main, posting to the main page achieves higher page views than not posting to main 65% of the time. Okay, we kind of expected that because posting to main is going to generate more page views. However, by selecting randomly and using more heuristic, posting to main achieves higher page views than not posting to main 78% of the time. So it's actually, choosing articles to post to main randomly will likely outperform using this 1,000 clicks on Twitter heuristic, which is kind of mind-blowing. So using this 1,000 clicks on Twitter heuristic to post is actually detrimental to the goal of achieving as many page views as possible. When we presented this information to our social team, they were like, whoa. Some of them had actually like raised the question, like, should we be using this heuristic? So it wasn't totally shocking to anyone, especially because like it's generally known that there are significant differences in the audiences on Twitter and Facebook. So in addition to this sort of myth busting, one of my other coworkers, he had worked on figuring out like the optimal number of Facebook posts a day for each Facebook page. So we sort of did this like tag team where I was like, hey, don't use this heuristic, and he was like, but here's a different heuristic you can use, because you never just want to like kill everyone's hopes and dreams all at once without giving them anything to hold on to. So that's also like a fine balance to strike. But it's also it's been very useful because after we presented this information, they used the information that my coworker provided to actually determine the number of things to post, and then stopped using Twitter clicks, and our views have actually gone up a little bit, which is pretty cool. Okay, so I have some final thoughts to wrap this up. Here's some takeaways. So audience data can be messy and complex. Sometimes you won't have all the data that you need. You can also do a ton of things with it. So I presented like a bunch of kind of like smaller things that I've done in the past year or so I've been at Mashable. But there's a number of other things that I didn't present that we've been working on. Like we've actually done a whole like competitive landscape analysis, looking at a bunch of other publishers like BuzzFeed and Gizmodo and Business Insider, and because we not only go out and crawl these pages, but we can get their Facebook posts from the Facebook API and sort of try to understand what are their social media distribution strategies. Is this working for them in terms of shares, and then try and like optimize our own. So another takeaway is to make data as usable as possible for non-technical stakeholders. You never just want to like drop a bunch of numbers on somebody and walk away, and they're like, what do I do with this? So also having an understanding of both the audience reading your content and the audience you're developing for or finding insights for, that's also good. Know what metrics you want to optimize for. It's maybe not going to be the same metrics every time. Know what your end goal is. So like if your end goal is something vague like, is this a good heuristic? That sounds like an easy question to answer, but it's not. You actually have to think about it a little bit more in depth. And then optimize for interpretability. So at the end of the day, again, we don't just hand off some numbers to the editorial team and then disappear. We strive to give them the best information possible to make their jobs easier. And their job is writing the right content, putting it in front of the right people at the right time. So we're trying to help them do this. So current and future work. Facebook index, I just mentioned that actually that's like the competitive landscape analysis. Velocity 2.0, we want to make the velocity algorithm a lot better. We would love to do a behavioral analysis of session data. That's been something we've been thinking about for a while. Headline optimization, we've got some headline optimization stuff in the works right now that another one of our data scientists is actually working on. And then all things video, because video is the future, as they say. So here's some resources, papers, and blog posts that were useful. The structural virality of online diffusion is a really awesome, amazing paper on how content spreads across the internet, so I highly recommend that. Archetypal analysis, also really interesting. I actually had never heard of that kind of analysis before I started working at Mashable. My manager was like, hey, this might be a useful audience segmentation technique. I have some Python packages and whatnot. I'll put my slides online somewhere so then you can actually like look at these. And that's really all that I have. Thank you for listening to me ramble on about audience analysis. You can find me on Twitter at Sarah_Guido. And yeah, that's about it. Thank you so much.
Thank you. That was a lot of data scientist theory.
Yeah.
And I think that kind of states the takeaway from the previous talk, that please do work together, engineers and data scientists.
Yes.
Yes, to obtain the goal.
Oh, yeah.
I have a couple of questions here.
Cool.
Other than Google Analytics, what sources of audience data do you use?
Yeah, so for demographics, we're currently just using Google Analytics. Unfortunately, we're trying to find a better solution. But we also have data like session data, like when you go to the website. You know, how long did you spend on each page? Where did you go? What's your journey? We can get Facebook, like aggregate data on Facebook. We can't get individual data on Facebook, which is fine. We don't necessarily ever want to say like, this is you, that person. We're also like constantly on the hunt for like better and new data sources. Yeah.
I have a number of questions regarding the limits for posting to Facebook. That might not exactly be your part of the company determining what to do there. Do you know what is the punishment for being too active?
If you're too active on Facebook, and this was not only like an anecdote that people on the social teams were saying, but my coworker actually studied this. If you post too actively, then Facebook stops like promoting your content in the newsfeed, so people don't really see it as frequently. That's about the extent that I know about that. But we also do a lot of work to try and figure out like, because we're actually at a point where we're starting to rebrand our Facebook pages because, as you saw, we have a bunch of followers on like our main page, but we have smaller numbers of followers on our secondary pages. We're actually trying to grow the audiences on our secondary pages. So we're starting to develop out more of a strategy in terms of like when and where to post. That's not just like throw everything on the main page, but like how do we drive people either from the main page to Facebook or go out and get new audiences for the secondary pages.
Here's a question for you as a Python geek. Is there a female term for geek-ass?
I'll take geek is fine.
What machine learning library do you prefer? What did you use here?
Scikit-learn. I think I use scikit-learn for everything except the archetypal analysis, because archetypal analysis is not part of scikit-learn. I actually listed the Python package that I use for archetype. It's for the archetypal analysis. It's the third bullet point there. But yeah, and my last point is scikit-learn documentation. I love scikit-learn. It's really great. It's really comprehensive. Sometimes if I'm doing more stats-based stuff, I use stats models. It's kind of nice. It has like the R syntax of like creating regression models, which can be nice. But yeah, I mostly use scikit-learn.
How's the learning curve there?
Yeah, so scikit-learn, the documentation is really written for people who already have a pretty good understanding of machine learning. It can be really hard for a beginner to just sort of dive in and start using scikit-learn. However, there are a lot of really great tutorials online that have been given at Python conferences like PyCon, often by people who actually commit code to the scikit-learn project. So if you're a beginner, I would definitely recommend like finding one of those tutorials and starting there and then diving into the documentation. Once you have like a decently good understanding of machine learning, the scikit-learn documentation is awesome. But yeah, the learning curve can be a little steep at first.
Okay, one final question. Did you consider using text analysis for doing your selection grouping?
Text analysis, for which, for audience segmentation?
Yeah.
Okay. Yeah, that would have been interesting. So I'm assuming text analysis means like a textual analysis of the URLs, or is that what that person means, maybe? That would be like, that I think is like the next thing that we want to do, is do like a much deeper content analysis of the kinds of articles that particular segments are interested in.
Yeah.
Yeah, we definitely want to do that. We've done some like topic modeling stuff at Mashable. We haven't done a ton of it. I'm really interested in that subject. I don't know too much about it, but the opportunity arises for me to do that. I would love to explore that a little bit more. Cool.
Thank you.
Thank you.